Let's talk now about paging. So the idea here is we're going to map a contiguous virtual address space to a non-contiguous physical address space. So let's look at how we're going to do that. So let's say this is memory here. That is, these are physical addresses. And we're going to break them up into what we're going to call frames or physical pages. So physical pages are all going to be of a fixed size. So we'll have start out like 0, K, 2K, 3K, 4K, etc. So our page size or frame size is K. K, a power of 2. Because pretty much all numbers in computer science are powers of 2. And then our logical address space is going to be something like this. Let's just make it the same width so it looks like sort of the same size. So here we have our process. And let's say we have a small process, and its address space is from 0 to 3K. And these are all supposed to be equal sized. So let's imagine each of these is equal size, of size K. And then what we're going to do is map these logical pages into physical pages, aka frames. So let's take one of these. So this is a physical page, or also called a frame. So we're going to set up a mapping that can be arbitrarily between a page in the logical address space and the physical address space. So it might be that the first one, so let's say, there's some content in here. Like, hey, this one might go down to here. So this is where something with the contents of A would be. And then this contains B, and this contains C. And this one might be up at the very first physical page. And this one might be, let's say, here at index 2. So we have this mapping between logical addresses and physical addresses. In that, anything in this first page, any address in this first page will be remapped to a location, within here. Okay, so if we think of it, if we look at some address here, let's say, it might be in it. So let's say K, just to make it simple, is 256. So we've got pages of size 256. And we have here the address 0, so this is in hexadecimal, 0, 7, 2. So that's within the first page. And the numbers in here would start with a OX1, and then another 8 bits, and OX2, and another 8 bits. So in this case, what would happen is we'd say, okay, we know 7, 2, So if we look at this, this is the page number, okay, the logical page number, and this is the offset within the page. And this would get converted via this mapping to (372). That is, we'd maintain the same offset, but the logical page number would be replaced with the virtual page number of OX300. We get a lot of flexibility by doing this.